Hello, my name is Benjamin Bobel, and I am a senior high school student. I worked with Dr. Del Eigel at the UC Davis Atmospheric Science Department to study patterns in cloud top temperatures on the West Coast. Now, patterns on the cloud top temperatures on the West Coast are not well documented compared to the East Coast. So we just wanted to see how it varied over time, mainly due to climate change and over geographies, maybe due to topography, maybe not, we did not know. Cloud top temperatures, for context, are very significant in determining the characteristics of the precipitation of a cloud and the radiative properties of the cloud. So there might be more snow depending on, or rain depending on the cloud top temperature. We wanted to, we needed a large enough sample size in order to get this information. So we, in order to get accurate information. And so we used the International Satellite Cloud Climatology Project, or ISCIPS database, which is one of the oldest, from 1983, to find our cloud top temperature trends. Our methodology basically used that database, plugged it into Python, used statistical analysis, so using histograms, means, whatever we wanted, to find any sort of significance. The data ranged, we wanted from winter, and so it's loosely winter from November to March. For 1983 to 2012, we wanted to see more rain cloud properties. The longitudes we looked at were between 235.5 and 245.5 degrees, and the latitudes were between 32 and 49 degrees. You can see that area right here. It's tried to minimize the ocean interference as much as possible, since oceans do affect cloud top temperatures, without minimizing the land mass interference. We had to restrict cloud optical depths, which is kind of a measure of absorptivity of clouds, and being greater than 20 to make sure clouds actually existed in our database, and that they're more likely to be rain clouds as higher cloud optical depth increases the likelihood of rain clouds. Now, for distribution, what we wanted to see in just overall, we find that it is a unimodal skewed left histogram right here, and it is, the mode is at freezing, which is, I do not know why clouds want to stay freezing, and it is heavily skewed left, meaning more temperatures wanted to be below than above that value. For our geographic results, for our latitude, we found a slight downward trend. It's not significant, so we do not consider that there was any true result, but as we go from south to north, we do notice it does cool down a little bit. That's probably because we're getting further from the equator. For longitudes, we note also a very slight downward trend. It's probably not significant, going from 256 to maybe 255.5-ish Kelvin. And if we think it might be because of mountains, because if we go west to east, on the west coast there's more mountains on the east overall, and so that would, we think, would decrease cloud top temperatures. It's also, again, not a very significant result. Now for time, we thought it was initially significant. This is a massive trend at negative 0.107 degrees Kelvin per year of a decrease. However, so that means in 10 years, cloud top temperatures would decrease by 1 degree Kelvin. However, our data seemed very weird. There is a pre-1994 cluster and a post-1994 cluster, so we think something happened in 1994. And indeed, something did. We don't know if this is the cause, but we think it might be, is that the GOES 8 satellite was launched, and which displaced the GOES 7 from its normal position over to the west coast, which may have altered the readings that it had. From 1995 to 2012, we had to correct it because we couldn't compare. We see almost no correlation. The slope is close to 0, and the R squared value is 9 times 10 to the negative 4th. So there's basically no correlation here for statistical significance. So in conclusion, we see that temperatures tend to stay around freezing, and that it's skewed left. This is warrants further research. I do not know why, and I think it would be interesting to see why. We know that the geographic results have very little trends. We see a few, but there's basically no statistical significance in the geographic trends for cloud top temperatures. Our long-term data, we realize, is flawed. All long-term data from the ISCIP may be flawed because they launch different satellites and get data from different satellites. And so we may have to use a different methodology or be able to adjust for the differences in cloud top temperatures or other variables within these satellites. Thank you for listening.